Alright, we are going to start with our PSAT practice. So, I actually really like this question. This question is pretty cool, and I think it has a lot of real-world applications that you can model off of this. It reads, to cut a lawn, Alan charges a fee of $15 for his equipment and $8.50 per hour cutting the lawn. Taylor charges a fee of $12 for his equipment and $9.25 an hour for cutting his lawn. If X represents the number of hours cutting the lawn, I'm actually going to change this to H for hours. What are all the values of H of hours for which Taylor's total charge is greater than Alan's total charge? Okay. So in order to solve this, we need to first set up our equations. Our equation, we're going to set it up for Alan first. So Alan's payment model would look like this. A $15 flat fee plus 8.50 times the number of hours he works. I'm just going to use H for number of hours. And then that's how much money he would get. Taylor charges a fee of $12 for his equipment. $12 for, and this is Taylor, plus $9.25 an hour. And that's equal to his payment model. So when you try and figure out at which point do we want to use each one. Clearly, if it's only for about an hour, we want to use his. Conversely, if it's for a very long time, we're going to want to use that one. But we need to figure out what exact time should we change it. And the easiest way to figure that out is figure out what time they're equal, their prices equal to each other. Well, if we want their prices to be equal to each other, we would just set these two equations equal. 15 plus 8.5h is equal to 12 plus 9.25h. Subtract 12 from both sides, and we get 3 plus 8.5h is equal to 9.25h. Subtract 8.5h minus 8.5h. Cancels out, and we get 3 is equal to, well, we have a difference of, if we had 50 cents, and we want to go to $1.25, how many quarters would we need? You need 3 quarters or 75. So we know the difference is 75. Oh, this is supposed to be an H here. Now, in order to solve for H, we need to divide both sides by 3. So we have H is equal to, oh, I'm sorry, I messed that up. I dropped my variables. Let me rewrite this. We know 3 is equal to 0.75 times H. We need to divide both sides by 0.75. And we get H is equal to, well, that's kind of hard to figure out what H is equal to, right? We have 3 divided by 0.75. This is where fractions are actually easier. We could rewrite this equation as 3 is equal to 3/4 times hours. 3/4 is the same as 0.75, right? So we can multiply both parts by 4 over 3. Multiply by 4 over 3. Cancels out, cancels out. This cancels out, and we're left over with 4 is equal to H. A little bit easier, isn't it? So we know if we had a timeline from 0 to 4 hours, at exactly 4 hours, they cost the same. But before 4 hours, it's cheaper to hire Alan. After 4 hours, it's cheaper to hire Taylor. And the question is asking, at what time should we hire Taylor over Allen. A. When x is greater than 4. Oh, I'm sorry, I switched these around. This one's Taylor. This one's Allen. Okay. All right, now we're going to do, what we learned yesterday is what we've been learning all week is we've been learning the trig functions, sine, cosine, tangent. Now we're going to learn the inverse functions. And the inverse functions, they look like this. You either have inverse sine, inverse cosine, inverse tangent. This is what they look like with a little -1. Sometimes you'll hear me say arctangent, or arcsine, arccosine, arctangent. Sometimes you hear me say that. Sometimes I label it as a sine, a cosine, a tangent, like this. There's a bunch of different ways to label it, but on your calculator that you guys use, the Texas Instrument uses this notation. They all mean the same thing. So, what is special about inverse sine, inverse cosine, and inverse tangent is that it undoes a sine function. So we want to specifically find the measurement of our reference angle. So we want to get that a by itself. So we want to cancel out sine. And in order to cancel out sine, we're going to use the inverse function, just like that. But you can't just do it to one side, you have to do it to the other. So we're going to do inverse sine over here. These cancel out, and we're given a, our reference angle, is equal to sine, inverse sine of 65. So in order to type this into the calculator, you need to type in 0.65. In order to type this into the calculator, you need to type in second sine, and you notice how there's a -1 now, of 0.65. 40.54. What does that mean? That means this reference angle is 40.54 degrees. Okay? Let's do the same thing for cosine B. We're going to take the inverse of both sides. This cancels out, and we get B is equal to cosine, inverse cosine of 2 over 3. Inverse cosine of 2 over 3 equals 48.19. Make sure you did, make sure it's in degrees, not radians. Hit mode. Type it in again. Sometimes you may have hit cosine instead of inverse cosine. Okay, now we're going to do the last one, inverse tangent. Inverse tangent of A, so this cancels out, and then inverse tangent of this number. A is equal to inverse tangent of 1.72. Plug into your calculator. Inverse tangent of 1.72, and we get 59.83. And remember, these are all in degrees. These are all measurements of angles. It doesn't have a symbol, it's in radians. Okay. All right. So the instructions explicitly tell us to find the measurement of A and B, but for right now on this page, I'm only going to find the measurement of A. So we have X here, we have A. That's what we're trying to find. We're trying to figure out what angle this is. In order to figure that out, you need to figure out what function we're going to use. We're going to use opposite here, and we're going to use an adjacent here. Hypotenuse is up there, but why am I not choosing hypotenuse? There's nothing there. There's no information. So, opposite and adjacent is, if you look on the board, tangent. Tangent of x is equal to opposite 6 over adjacent 20. So instead of having the x over here, like we had before, it's now right in here, the reference angle. We're going to take inverse tangent of both sides. This cancels out, and we get x is equal to tangent -1 of 6 over 20. You don't have to write this step out. I'm probably going to stop writing it now. Inverse tangent of 6 over 20 is equal to 16.7. So we know this is 16.7 degrees. I actually think that's pretty cool, personally. Oh, don't worry, we will. Get that clap. Okay. Excuse me? I think she did. Is that... She's turning really red right now. Guess I'll just have to call your parents and tell them what you said to your teachers. Sounds like you actually care. Okay. All right. We're going to try to solve for A over here. We need to figure out where our opposite is. Our opposite's here. We have an adjacent, which is right here, and a hypotenuse here. We only know two pieces of information. We know the adjacent and the hypotenuse, that is cosine. Cosine of x is equal to adjacent 5 over hypotenuse 15. We're going to take the inverse function of both. I'm going to not skip that step a little bit. And now all we have to do is type it into the calculator. I took the inverse of both sides, and I just skipped that step, actually writing it down. You don't have to write that step down. And I got x is equal to 70.53 degrees. Okay? On the next set of examples, because it's more complicated, and now we're going to solve B now. Okay. Now in order to find B, or we're going to find A and B. I'm going to start here at X. Same step as before. We have an opposite. We have a hypotenuse. An opposite and hypotenuse is going to be, what is it going to be? What's opposite hypotenuse? Sine of X is equal to 0,9 over hypotenuse 21. X is equal to inverse sine of 9 over 21. Inverse sine of 9 and 21 is X is equal to 25.38. Now, we don't actually need to use trigonometry to figure out the last angle. We could. It's not the easiest way. We know this angle is 25. We know this angle is 25.38 degrees, right? We know that's 90. We know all three of these angles need to add up to be 180. So couldn't we just subtract 180 minus 90 minus... But there's an even shorter shortcut. We don't even have to do 180. We know since it's a right triangle, it will always be minus 90, right? What's 180 minus 90? 90. So it's always, this last angle you'll always be able to get by doing 90 minus the angle you just found. So if I do minus 90 from here, it's not going to be a negative number, right? I should have done 90 minus this number, correct? But I was lazy and typed it in this way. We think the answer is going to be 64.23 degrees. Now, who can think of why that could be wrong? There's two big reasons why that could be wrong. The rounding, we might round wrong, and it'll cause weird numbers. It might not be perfect here. In fact, it probably... Oh, see, even I rounded wrong. That's 2... Oh, sorry, 62. Okay. Another reason why this could be wrong, and this is the big reason why, once if we did this wrong, then we're going to get this one wrong for sure, because these two answers are related to each other now. So if you do this way, be prepared to miss both questions instead of just one. Does that make sense? So that's one reason why I would avoid against it, but I'm showing it to you just so you guys know it's out there. Well, I'm going to use the trig way now. We're going to start here at this B. We're going to call this Y now. I'm telling you, you can do either way. Just know that there's mistakes that can be made using this way. Y starts here. Now you have to redraw your opposite and your opposite adjacent hypotenuse because they change. This becomes your opposite. This becomes your adjacent, and then this becomes your hypotenuse. These two switched around. Remember, when you switch the reference angle, the opposite and adjacent switch with it. So now instead of having sine, we're going to have adjacent hypotenuse, which is cosine of y is equal to 9 adjacent over hypotenuse, which is 21. Y is equal to inverse cosine of 9 over 21. And if we did this correctly, we should get this number. Inverse cosine of 9 divided by 21. Oh, wow. Look at that. Okay. So we know y is equal to 64.62. So really, I guess it all depends. How confident are you on your trigonometry? If you're super confident on your trigonometry, the way I did it up here, way easier, way less steps. It requires 3 calculator strokes and you get the other angle. If you're not too confident, then you have to do it both this way too. Alright. You guys are going to have 2 quizzes tomorrow. Well, one's going to be a quiz, the other one's going to be a homework quiz.